All right, so this is great. I'm really glad to be here. Start my timer. So just a little bit of the motivation for this talk. I was really inspired to really delve into this work almost a couple decades ago now. The World Trade Center Memorial Competition with the 9/11 attacks. I did this interactive sculpture grappling with tension, grappling with the idea of disparation and discord between different cultures that are just seeing things differently, and then realizing. So that was my sort of embedded in my architectural practice, but then going back to like my environmental work and my physical chemistry, I really kind of wanted to understand how it is that life, in essence, like at first you think of this the ability to deal with tension as like this something like that's just intrinsically toxic, this notion of tension. But then through the course of this research, realized that no, actually life intrinsically, or what I'll talk about in this talk, semiogenesis, requires tension, that's one of the central features of the emergence of life itself and semiosis. And then, of course, in the larger scheme of things, really looking forward, as Tori Alexander mentioned, doing some work with you guys and working with Dawn on how it is determinacy emerges out of indeterminacy. Really hope to contribute to this larger conversation of semiotics. So I'll split this talk into three parts. The first part is just sort of forming the question, like trying to understand the question starting out, and then through this out of my architectural practice, coming up with an intuition. And then the next final two sections will look at semiogenesis, somewhat rigorously in theory, and then somewhat rigorously in practice. So starting with something perhaps more familiar to folks is just a good old architectural practice. So what was interesting about this is that the idea that, for example, in architecture, we do a lot of sketches in order to grapple with what are in essence a bunch of contradictory constraints. We have to deal with the site, the client needs, the structural parameters, and a lot of times all these constraints, if you will, really compete with each other. And so what we were taught in grad school, interestingly enough, is to essentially allow all these disparate constraints. You just hold these in our mind, and then just wait for the solution to emerge. I mean, that's literally what we're taught in grad school. And believe it or not, it works. So the trick is, though, is you think that the process, people talk about process, they're really talking about, these sketches up here, and these are just two of, hundreds of sketches that you literally superpose on each other, such that we use trace, right? So we use this semi-transparent paper, and layers upon layers, you all have like 20 of these pieces of trace, and you'll literally be seeing all these different layers, this history superpose on itself, as each layer is really just a capture, maybe Nora Bateson's hints, if you will, that they're just sort of states. They just capture states. But it's really important to realize that they're not the actual process. This isn't where creativity actually lives. It actually lives in the gaps. It lives in the gaps. What I realized is that, that mysterious thing that our professors told us to do is just allowing the solution to emerge from the chaos, if you will. So just to reiterate, the sketches are not, the process themselves. And what I realized later is that there's infinite potential. Well, I guess every architect sort of realizes at some point that that you could have an infinite number of design possibilities in any given project. And then on top of that, you could have an infinite number of possibilities between each sketch, to go from this sketch to this sketch, thinking of all the different parameters in their disparation, in their conflict, in their tension, coming up with solutions that deal with both of those, all those different constraints. Really dips into a kind of a literal infinite number of possibilities. So I was just fascinated with how this was remotely possible. So then a little U-turn here. This actually goes back to my undergrad work. So before I went into architecture, I studied physical chemistry and environmental sciences. And then in order to really dig into understanding how this might be possible, I thought I should really dig down deep in order to not fall into too many fallacies. So I went down into quantum mechanics, and what's really interesting about, depending on your interpretation of quantum mechanics, is that here too, quantum mechanics is also grappling with this paradox between continuity and discontinuity. In other words, you have this process which seems like this continuous thing, but then you have these sketches, these intermittent sketches that you do that are sort of capturing the process, but they're really just very minimal reflections of a much, much deeper infinity. And again, when I use the word infinity, I mean that quite literally. So for example, in quantum mechanics, this isn't a stretch. This is just the Schrodinger and the Copenhagen interpretation, essentially looking at how it is that a particle, so to speak, is essentially a sparse coherence, constructive interference amongst an infinity, a literal infinity of possible momenta. Right. And so this completely gets to the heart of Heisenberg's uncertainty principle, and that this last portion down here is actually an impossibility. Like, this is what Heisenberg's uncertainty principle is saying we cannot do. In other words, perfectly localize where the particle is, because it's necessarily, each particle is necessarily born of, emerges from all the momenta, the continuous distributed momenta. Now, this gets to philosophical considerations of difference and disparation, and all the way from Guibert Simondon to Donna Haraway, this idea that it's relations all the way down really is something that I came to believe. But it's important to be careful here because, so I looked at what Peirce had to say about this, and I was heartened when I looked at his collected papers that firstness is really would put the emphasis on the potential relations, right? So this particle is a potential particle, right? Because it depends on the relation between the infinity of momenta. And so, Guibert Simondon, for example, would actually largely agree with this, this idea of potential. And this, I think, resonates a bit with what Don was talking about in his talk. Okay, so this brings me to my intuition in trying to grapple with how it is life leverages the tension, leverages the so-called noise. So if you have this interference pattern, say, just drops on a pond, right? It's simultaneously, each drop can be thought of as a distinct event, but that simultaneously these ripples illustrate the interference pattern that they all share. And so that the pattern as a whole entails physically both the distinct events and their interrelation simultaneously. And so that this continuous medium is both both the distinctions and their interrelations. And it was kind of funny. It was really a mundane experience. It's kind of an everyday experience. I came up with this. Again, I was grappling with how it is I would do this interactive sculpture for the World Trade Center competition, and I really wanted this way that visitors to the World Trade Center Memorial could see themselves reflected in an interactive sculpture, and it raised all these philosophical problems that I just mentioned. And then I was in my kitchen and I was just looking at a baking dish filled with water, soaking as we all do. And the sunlight was coming in through the window, bouncing off the water and then reflecting onto the wall. And I bumped the dish and all these ripples started. And I looked at the reflection on the wall and I was just, I was just blown away with the idea that all these different disparate kinds of constraints, the dish, the sunlight, the transduction of my having bumped the dish, all became I don't want to say represented, but entailed, if you will, in the reflection on the wall. And I realized this dynamic reflection that was dancing on my wall had an infinity of possibilities. But that infinity of possibilities was constrained by each of these superposed, in the interference pattern, entailed the superposition of these distinct realities. These distinct phenomena came together as kind of one, if you will. But then I, of course, realized that that's all fine and good, but in quantum mechanics, superposition is a linear phenomenon, meaning that, well, to put it loosely, the waves are transparent to each other. Like they don't, the interference pattern, they'll flow through each other like these ripples, but they have no memory of each other in a sense. So I had to grapple with that because obviously that's not how semiogenesis ultimately needs to work. So then I was playing a lot of music at the time. So I took this idea of the interference pattern and I imagined like, okay, where else does this happen where you don't have just waves, you have sort of a nonlinear aspect. And I thought of musicians like symphony, or probably a better example would be jazz improv. So you have some musicians and that they're literally co-molding a common medium, right? So that interference pattern is literally manifested in the acoustic patterns in and amongst themselves. Like each musician is putting themselves a pattern into that shared milieu, while simultaneously what they're getting back is the superposition of everyone's pattern. So you could imagine all the dissonance if you're, not a very good musician that comes back to you, or as you sort of respond to this collective, you change your behavior. And so the musicians both form and are formed by their shared interstitial medium. But of course, here too, we run into another problem, which is that I've assumed semiotic agents. I've assumed it's sort of a homuncular fallacy, if you will. Like I'm trying to explain semiogenesis, like how it's possible, but I've assumed a semiotic agent. Let me skip that slide. So this then goes into section 2 of the talk about semiogenesis.
Just Josh, you have 5 minutes.
Oh, okay, great, thank you. Okay, so the neurons, I started started researching neuroscience and okay, how could this be possible in the brain, for example? And it was I quite quickly realized that that through local field potential and different phenomena in the brain, whether it's electromagnetic, which is local field potential, or chemical gradients, reaction diffusion phenomena in the brain, that it was quite possible that the neurons themselves would have an interstitial milieu, could have an interference pattern, and so that you could have, because no one really, in doing my research, I found that even if you look at spike timing dependent plasticity and all the latest models of the timing, spike timing and all that kind of stuff, no one was really answering the question of how it is that these that neurons literally rewire themselves in a way that's not simply stochastic, that's not simply that they're wandering around in the dark, right? Because we have this idea that we've over-reified the notion of the action potential in the neuron, like these little machines, and that they're just sending, they're just in the dark with respect to each other. And I said, what if they weren't necessarily in the dark, that they had these very ephemeral, and to use the term diaphanous that Nora Bateson mentioned yesterday, is a great term, diaphanous, semi-transparent, superposed patterns in and amongst them, that they could it's a milieu, again, like the musician example, that they all form and are formed by, and that in this simultaneously superposed milieu, that they could move towards ever higher levels of complexity and in formation, so that they're growing along the constructive interference, so to speak, in these interference patterns. But again, the neurons themselves are superposed semetic agents. And so in this process of formalization of really answering our question, can we simultaneously simplify our model and work out, again, a kind of a homuncular fallacy? So this moves to a project that I actually gave a good portion of this talk at the 2012 Bateson Idea Group in Asilomar. And so how this works is that instead of neurons, you'd have these, what I call primary nodes, these dark nodes that have frequencies over them. And what those frequencies in hertz are indicating is sympathies. In other words, like a tuning fork, if you will. I mean, each of these nodes would be more complex than a tuning fork. But what they would do is they would respond to, say, a C major chord and in the environment, from the environment. And then each of these nodes would differentially respond to that environmental stimulation, and that create an interference pattern. Say in this example, in this model, might just be an electromagnetic shared milieu. And then be able to, via these secondary nodes, which are the more numerous gray dots in between them, be able to discern the energy differential as sort of like a gestalt, like a very dynamic gestalt figure ground kind of a thing, this ephemeral gestalt, that they're sensing the differential order, and then be able to bias the network. So this answers this really fundamental question of how it is that the network biases itself in a non-stochastic adaptive way, so that in the future, so that you start with an unbiased network and then you move to a biased network, and then the biased network not only is sensitive to individual notes, so to speak, but also to groups of notes, a chord, if you will. And that brings me to complexity. So my definition in that 2013 paper for complexity is exactly this idea that that you have these different levels of dynamics, that as the network biases itself, you have the first level attractor A, let's say, which is like the C major chord I was talking about in the last slide. And then let's imagine that exact same finite matrix, that exact same distribution of the exact same physical matrix could also become differentially sensitive to another attractor, say attractor B, which might be an E minor. Now we can imagine that once those biases are instantiated physically in the system, so that it's sensitive to these distinct patterns, that then those can now be can co-occur to create what I believe is like C major seventh or something. I mean, the music theory doesn't really matter. The point is that you have now a second level attractor, because you're building off of, you're not getting rid of these former patterns. Those former patterns still exist in this second level attractor here, but it's a distinct pattern. It's fundamentally a new pattern that's composed of the other patterns. So this is the final slide for the theory section, and I'll go very quickly through the practice section. But to summarize the theory, the idea is that, and this gets to semiogenesis, like a somewhat formal definition of semiogenesis, which in my 2013 paper I called refinement, which for you Simondonians out there, you could loosely think of what he would call thinking individuation, or individuated thinking. Not life, because the system is not living. That's not the claim I'm making. But what happens is that over time, you could imagine these parabolae, again, this parabola here, as the system develops, as it incorporates more and more biases, and then patterns of patterns, patterns of patterns of patterns, et cetera, that this Umwelt, if you will, would grow. And necessarily, and I don't have time to get into it, but relevance necessarily has to kind of oscillate. This is really important because what this system is not doing is minimizing or maximizing. All this free energy principle and all the maximum entropy models, I argue, that over-cohere on a single attractor, like even neural networks are, cohering on a single attractor. That's what I would call a death state. You need to oscillate like an annealing schedule, if you will, and that the relevance as it anneals, as it coheres and then decoheres, coheres and then decoheres, as it ratchets, and this trajectory here, this trajectory along sort of the average of relevance oscillating in its sort of homeostatic envelope, if you will, that this trajectory, this polynomial regression is semiogenesis. That this is the acquisition of new signs internally, the internal generation of new signs.
20 minutes.
Great, thank you. Okay, just a couple slides here to sort of sum up where things are with all of this. So this was part of a poster I did for the cognitive science folks over at Berkeley back in 2012. And it's funny, I actually ran into Christoph Koch, who was hugely inspirational for me with his work on ephaptic coupling, basically showing that you couldn't explain neural activity based solely on spike timing, dependent plasticity, that there was something else going on. And he was the one actually who empirically showed that there needed to be something else going on to explain how it is neurons did what they did. And I talked to him, I was like, oh, what about local field potential and having it being causal and, feeding back and He wasn't into it. So anyway, back in 2012, this wasn't even really a very popular idea, but I'm really excited about the biosemiotic community because I feel like there's some kindred spirits here with this, with the people being more comfortable with this sort of infinite possibility space, this noise, if you will, the interference pattern here, and that I'm representing with the purple here, which is just like a section, if you will, through a three-dimensional interference pattern. And then again, you have the primary nodes and then the blue secondary nodes measuring the differential order, the sparse order, in harnessing the sparse order in the noise. And then this is just talking about sort of where the design is. I've done some, I've tried to build this thing, but that's a whole nother degree. That you have a digital portion, but necessarily you have to have an analog portion. And when I say analog, I don't mean just analog computing. I mean non-Turing equivalent form of icon, because fundamentally you're dipping into, what Don was talking about in his talk, this sort of the infinity of the indeterminacy. That's a fundamental part that's being leveraged, and it has to be physically manifested. And then it could be harvested, that it could be harnessed. And then this is just showing how you might have a software layer that's then creating in real time, in essence, updating the biases in response to the secondary nodes, sensing, feeling the interstitial pattern. This is just really quickly what empirical data might look like if we were to accept the alternative hypothesis of what I'm proposing here, that semiogenesis would literally be these biases accruing, and that as you're accruing those biases, you're literally able to do more adaptive work. And then this is second to the last slide. This is just, again, really as Victoria Alexander just mentioned in the last talk, some work that I'm doing with both her and Oscar Castro. This over here on I guess would be the right, is a sketch that Tori and I were going back and forth on, trying to understand the Kirimoto model, which is a really fascinating model going back like 40 years, how it is chemical oscillators could cohere or decohere in such a way that emerging out of this really large population of diversely tuned chemical oscillators, you could get the capacity for a slime mold to have internalized an external, the periodicity, the frequency of an external stimulation And then we argue that this is a form of iconicity that's intrinsically being and non-stochastically emerging. And then we get further, as Tori already talked about, get further into how indexicality might also be a part of this. So to sum up, I just want to kind of get back to a slightly more informal definition for semiogenesis, which is a process whereby a system continually increases its average relevance, as illustrated by engagement, sensitivity, Umwelt, or potential awareness, to its surroundings by increasing its own internal capacity to harness the sparse order within the so-called noise, the result of increased relevance, into an ever more complex internal structure able to increase capacity to do complex work. Thank you.
Josh, that was absolutely wonderful. We've only got 2 minutes. I can't imagine this is not going to have a million comments. They're going to have to wait till the discussion session, though, because we only have 60 seconds. But Josh, if you go to your slide 13 really quick. I'm taking a privilege here. 13.
I'm sorry?
13. Yeah, I'm taking a privilege here. No, this one, yeah. The next one. Yeah, okay, same thing on the left. If I could think of a model of what the sign, vehicle, interpretant, and object consist in, for me, it would be precisely these interactions. I'll leave that there, and we'll go to our next talk. And in the discussion session, I'm sure there'll be plenty to discuss. Okay, but we want to stay on time so that we can leave. Okay.
Totally.
Okay. So, yeah. No, Josh, you can certainly respond to that.
Oh, yeah. No, I mean, I'm happy to yeah, well, we can wait till the,
because that would be semiogenesis. Yeah, at this moment, when
yeah,
all of these things are, then you have a sign. Okay.
Yeah.
But we'll talk. But it also, I think, that helps us think better about what an object really is. It's not a referent in the world. It's not a thing.
Well,
what a
that's
sign, purpose, mentomen is, and what an interpretant is.
Yeah,
right?
I will say one thing really quickly is just that I think what Simondon in his work, and I was really heartened to discover, thanks to Jagmer Dennison, discover Simondon, that he's really carefully pointing out that you can't presuppose, in talking about relation, you can't presuppose the relata, right? You have to explain those two first. And it's a really difficult, it's a paradox, because how do you explain a relation without things being presupposing things being related? So that diagram for sure is definitely trying not to make that presupposition.
Right, but to show how those relata actually will emerge
as formal
relations with each other. Because a sign is only a formal relation.
Icons, icons, then the patterns, and then the association of distinct icons as indexicality, etc. Yeah.
Right. Great.